So the last trend we're going to talk about for this chapter is that of electron affinity. So we just got done talking about ionization energy, and the ionization energy was the energy required to remove electrons from a species. Electron affinity is kind of the flip side of that. It's the energy that is released when an electron is added to the gaseous state atom or ion. And it's often a negative sign, and what a negative sign means is that when this occurs, when an electron is added, energy is actually released from the species, and so it's a net positive energy to the universe. Yay! So the more negative, or the greater the negative energy is, the greater the delta E is, or the electron affinity is. As long as it's a negative value, that means it's most likely to form an anion. This is the way chemists write electron affinities. They say an atom, or sometimes an ion, so like chlorine in the gaseous state, will add an electron, because we're adding an electron to the chlorine atom or ion. And then when that happens, it's got one more electron, right? So it has a -1 charge. If we had chlorine minus here, we could add an electron, and then this would be a -2 charge, and it would have a different delta E. And you'll see the only trend, and it's not a really good trend, this is kind of one of the worst trends here, but the only trend for that is that as you move from left to right on the periodic table, the elements on the right-hand sides tend to have the greatest negative values. That is, that they have the largest electron affinities and are most likely to add electrons, which shouldn't come as a surprise for you, because you know that the ions that tend to form from oxygen are negative ions. The ions that tend to form from fluorine are negative ions, and so you would expect that these are more likely to actually pick up extra electrons.